All right, coterminal angles. These are angles whose terminal sides, their ending sides, coincide. So what we're going to do now is we're not going to graph these. We're going to actually look for coterminal angles. We're going to find them. And the way that we're going to do this is by adding or subtracting a full circle, 360 or 2 pi. So the reason that we use 360 or 2 pi is because that represents a full rotation. All right, and we don't want them to always end at the same place. So if we look here, 395, this is actually already bigger than 360. And since I want a positive and a negative angle, if I subtract 360 from 395, that's going to give me 35 degrees, which is positive. If I want a negative angle, I'm not going to get a negative angle by adding 360 to this, so I'm going to go ahead and subtract 360 again. But I'm going to subtract it from 35 where I left off. So 35 minus 360 is going to give me negative 325 degrees. So if you look here, I now have a positive angle and a negative angle, where if I graphed these, they would look just like this. Let me show you on this one. All right, so I'm going to start. Let's just go ahead and graph this 35, the positive one. So I know it doesn't matter what, it always starts right there. So 35 degrees is a nice little acute angle right here. So there's 35 degrees. All right, now let's go ahead and graph the given one, that 395. So I know 395 is bigger than a full circle, so it goes around and then it goes to here. So it started and ended in the same spot. If I graph negative 325, again, it's going to start in the same spot right here. But this time I'm going to rotate around the other direction. So when I come back around, that's at negative 270 right now. If I come all the way to here, it's negative 360, so it ends in the same spot. So I just have a bunch of colorful circles now. All three of these look like the same angle. The only thing different is our rotational arrows. All right, so I'm not going to do that again. We're just going to find a positive and a negative angle that would be the same, a coterminal angle as 165. So since that's in degrees, we're just going to add and subtract 360. Sometimes you keep adding 360, sometimes you keep subtracting 360. Just keep doing it until you get a positive and a negative answer. So I've got 165 minus 360. If I do that, I get negative 195. So there's a negative angle. If I go back to that 165, my original one, and I add 360, I get 525, which is a nice positive angle. So I've got a positive and a negative coterminal angle. If I were to graph all three of those, it would look something like this, where they start and end at the same spot. All right, now I'm going to give you a radian measure. So since this is a radian, this time we're going to add or subtract a full circle, but in radian, 2 pi. Notice that's over 3, so let's go ahead and just convert that to 6 pi over 3. So we'll do plus or minus 6 pi over 3. So I'll start with 2 pi over 3 minus 6 pi over 3. Again, that's just a full circle. 2 minus 6 is negative 4 pi over 3. So there's a negative angle. I'm going to go back to my original 2 pi over 3, and I'm going to add 6 pi over 3. That's going to give me 8 pi over 3. So again, if I were to graph the positive, the negative, and the original, they would all, kind of look the same. All right. Reference angle. Now, if you look, we're going to get like some of these really big or really small angles. So we need something to refer to do work. We're going to get into doing work with these. So a reference angle, first of all, is always acute. It's formed by the terminal side and the x-axis. So that's huge here. It's always going to be formed by the x-axis. So one side of my angle will always touch this. Let me draw an angle here. So my angle usually starts right here. There's my initial side. I'm just going to make any kind of angle. I don't think it really matters. So there's an angle. Going in this direction, I'm going to call it theta. So that's my angle theta. Now, I need a reference angle. And the reason we need a reference angle, we're going to make acute triangles soon. Not yet. So I need to include my terminal side and the x-axis. So I want the x-axis that's going to make this be an acute angle. So do you see how I just kind of made another angle there? And we're going to call it theta prime. So whenever we see a reference angle, we're always going to call that theta prime. All right. All right, so this is just kind of a little help guide. And after we start doing some practice, it'll make more sense. But I only labeled the x-axis because, again, that's all I really care about there. So I just put a 180 and a 360. If I make an angle that ends up being in this quadrant, we're going to find out what the reference angle is by doing 180 minus theta. If I want the reference angle in this first quadrant, it's just going to be the same as theta. So it's always just going to be the same. That's the easy one. If the reference angle is in, or if my angle ends up terminal side in the third quadrant, I'm going to have to do theta because it's bigger than it, minus 180. And if it's in this quadrant, I'm going to do 360 minus theta. Again, this probably sounds really confusing right now, but it's going to help once we start doing examples. Then in a little bit, we're going to do some radian angles. So again, I'm only going to refer to the x-axis. If I am in the first quadrant, theta is just going to be the same, or my reference angle will be the same as theta. If it ends in the second quadrant, like this one did here, I'm going to do pi minus whatever the angle was. If it's in the third quadrant, it's going to be theta minus pi. And if it's in this fourth quadrant, I'm going to do 2 pi minus theta. All right, let's actually do some of these so you can see what I'm talking about here. All right, so I'm going to go ahead and draw my xy axis. So this is just more practice graphing the angles, and then we're going to have to find the reference angle. So I'm graphing 120 degrees. Initial side always starts here, always. 120 doesn't quite make it to 180, but it's bigger than 90. So 120 is going to be in this quadrant. Put it right there. All right, so here is my theta, 120. The reference angle has to be acute. It has to touch the terminal side, and it has to touch the x-axis right here. So this is my reference angle. Now I need to know how big that is. So you see here how this angle right here, this pink one, is 120. And if I were to go all the way over here, I'm at 180. So in order to find the reference angle, I'm going to have to do 180 degrees minus 120 degrees. And then that tells me that that reference angle is 60 degrees. So do you see how I did 180 minus theta, just like I showed there? Let's try the next one. All right, so this time I'm going to graph a 290 degree angle. So this is a very big angle. It's going to start in the same initial position they all do. Now it's going to go past 180. It's going to go past 270. It's going to be somewhere in this fourth quadrant, so about right there. So this right here is showing my 290 degree angle. That's theta. I need an acute angle, so hopefully you can see that acute angle right here. It always has to touch the terminal side, and it has to touch the x-axis. It will never touch this y-axis. So this angle right here is my reference angle. So since that's in the fourth quadrant, I know it's not quite a full circle, it's smaller than a full circle, which is why we're going to do 360 minus whatever the angle was. So 360 minus 290. My reference angle this time is 70 degrees. Again, it should always be acute. Take a look at the next one. I'm going to start where they all start. 200 is bigger than 180, so it's going to go to about right there. So there's my angle. My reference angle has to touch the terminal side and it has to touch the x-axis. So it's right here. There's my reference angle. So do you see how the actual angle is bigger than 180? So I'm going to do the angle, which was 200, minus 180. So that's what I was doing right here. Gives me the reference angle is 20 degrees. All right, last one here. All right, so I'm going to start in my initial position, just where they all start, right here. This is 60 degrees. It's already an acute angle, so it's going to be right here. So in this case, since that's a 60-degree angle, my reference angle has to touch the terminal side and the x-axis. It's actually the exact same thing. So my reference angle this time is 60. It's the same because it was in the first quadrant. All right, let's go ahead and try some radians. All right, so notice I labeled my pi and my 2 pi. I want to convert these so that they're the same measurements, in thirds. So I'm going to change this to 3 pi over 3. I'm going to change this one to 6 pi over 3. All right, so initial side, always right here. And then I want to get to 5 pi over 3. So that's going to be almost a full circle. It's going to get really close to that 6 pi over 3. I went all the way around like this. My reference angle is going to touch the terminal side and it's going to touch the x-axis. So there's my reference angle. What I'm going to have to do here, this was 5 pi over 3, to figure out how big that reference angle is, I'm going to have to do 6 pi over 3 minus 5 pi over 3, and that gives me a reference angle of pi over 3. So there's my reference angle. Let's try next one. This one is in fourths, so I'm going to change my pi to 4 pi over 4 and my 2 pi to 8 pi over 4. 8 over 4 is 2. My initial side is right here. 7 pi over 4 is going to end in this quadrant. It's going to go all the way around like that, which means my reference angle touches the terminal side and the x-axis. So to get this one, I'm going to have to do 8 pi over 4, a full circle, minus 7 pi over 4, which gives me a reference angle of pi over 4. Next one, 5 pi over 6. I'm going to start with my initial side, which is always the same place. I'm going to change this to 6 pi over 6 since I'm working with 6. This would be 12 pi over 6. So 5 pi over 6 isn't going to make it all the way to half a circle. So it's going to be about right there. There was my angle, 5 pi over 6. My reference angle touches the terminal side and the x-axis. So it's that little one right there. To get this reference angle, I'm going to have to do 6 pi over 6 minus 5 pi over 6, which gives me a reference angle of pi over 6. Hopefully you're noticing that if it's over 3, you're just going to get pi over 3. If it's over 4, you're going to get pi over 4. If it's over 6, you're going to get pi over 6. The last one is actually more than a full circle. So I'm going to find a coterminal angle so that I don't have to spin this around. So I'm going to take off a full circle, which is 12 pi over 6. So 19 minus 12 gives me 7 pi over 6. When I graph 7 pi over 6, it's going to be bigger than 6 pi over 6, so it's going to go around past that. My reference angle is going to touch the x-axis and the terminal side. So to get this one now, I'm going to have to do 7 pi over 6 because it was bigger, and then subtract 6 pi over 6. So this reference angle is also pi over 6. It's just that it was in a different quadrant. All right, you guys go ahead and try these, and I'll see you later.